Okay, we're going to look at solving systems of equations, and some of this might be familiar to something that you've seen before. So we're going to start with actually a word problem, and then we're going to set up our own system of equations to solve in a couple different ways to help us to review. So the situation is written there for you, and this is from page 89 of your book. And so it says ticket prices for a movie are blank for general admission and blank for seniors. Receipts for one show were blank for an audience of blank people. How many of each type of ticket were sold? So I purposely took out some important details because I want you to understand what the actual situation is before we start going to write equations. And so I want to give you a minute to think about what information you would like to know. So you should pause, reread the couple statements, and think about what information you would like to know in order to actually answer the question, which was how many of each type of ticket were sold. So now that you paused it and you've come up with some questions, let's see if I can answer some of your questions. So the first thing, how many of each type of ticket? Maybe you're asking, like, what does it mean by type? Well, reading back in there really quick, those two types were the general admission and then also the seniors. So then maybe you had a question of how much is it for each ticket? And so I could tell you that. So it costs actually $10 at this particular theater for general admission, and it costs $6 for seniors. And so maybe you want to know also how much money they made altogether. So actually when it says the receipts for one show, I'll tell you that the total amount of receipts was for $1,740. And maybe another question about how many total people were there, how many tickets were actually sold. And I'll get you that one. That's 190 people were actually there. Okay, so I kind of see two things here myself, that there's like money involved, but then there's also the total people. And so when we look at the question, it wants to know how many of each type. So it actually wants to know the total of the general admin people. And then we also want to know the total of the seniors. So we could define variables here for each of those groups. So you can use X and Y, but I really like to use letters that represent the thing we're talking about. So I'm going to let G equal the total of the total number of general admission tickets, and S to be the total number of senior admission tickets. So we could say the tickets. So anytime that you are defining a variable, just remember that G is a number and S is a number, or whatever letter that you use, that it is representing a number. So if you go and you try and describe it or define it, it should talk about a number in some way. What you should not do is say that G is general and S is seniors, because what does that even mean? Seniors is a noun, it's a word, it's not a number. So you want to say S is the total number or something like that, not just writing general and senior. So our situation, we know that it costs $10 for each general admission and $6 for each senior. So just in my head, if I'm thinking about it, well, suppose that there were 3 general admission tickets and they're $10 each. So I know that like that would be $30. If there were 7 general tickets, again at $10 each, I know that would be $70. So I don't know how many general admission tickets are. That was represented by the letter G. So if I write 10 times G, this would tell me how much money was made off of those, off the general admission. And then I could do it similarly for the seniors. So if I add to that, the senior tickets cost $6 each. So 6 times the number of senior tickets sold. This expression would represent the money made on the seniors tickets. And so I know altogether that there was $1,740 made with the sale of tickets. So what I've just done is I've created an equation in 2 variables. And so to create a system of equations means that I'm going to have more than one. So I have another piece that I haven't used yet, and that was the 190 people. So that's a total. So that makes me want to write equals 190. Now this is like the physical people. It has nothing to do with money. So I don't want to write like 10G plus 6S. But what I can do is just write G because that was the number of general admission people. S is the total number of seniors. So that should make sense that that would be the total people involved. So this is now my system. So I'm going to rewrite that a little bit simpler. So 10G plus 6S equals 1740, and G plus S equals 190. So this is my little system that I want to solve. So there's really two ways to solve it, and we're going to go through both of those. So one way is called the elimination, or some people might even know it as the addition method. And I kind of say both of them interchangeably because they kind of tell me the two things that I'm going to do. I'm going to eliminate a variable, and I'm going to do it by doing some sort of addition. And so when I look at the equations that I have, if I were to try and just add the equations together, if I add the lefts together, because those two guys are equal, like if I add this and then I add this, since G plus S is equal to 190, if I add G plus S to one side and 190 to the other side, I'm still maintaining balance. So let's go back and simplify this a little bit. So if I add it as is, I get like 11G plus 7S equals whatever number, but that didn't eliminate a variable. I need to eliminate a variable. So to do that, I can rewrite one of my equations by multiplying by something nice. And so what I mean here is, like, if I want my G's to cancel, 10G and G, the only way they cancel if I have a 10G and a negative 10G. So I'm going to multiply the left side of the equation by negative 10 and also the right side by negative 10 to maintain balance. And so what happens, the first equation I didn't do anything to. It's still 10G plus 6S equals 1740. But I'm going to take the second equation and rewrite that as negative 10G minus 10S equals negative 1900. And so again, if I add the two left sides together and then add the two right sides together, this would still maintain balance in my equation. But look what happens now. If I add the left sides, my G's will cancel. So if I take 6S minus 10S, that makes negative 4S. And then on the right side, when I take 1740 minus the 1900, I end up with negative 160. And so now, after doing the actual elimination, where I eliminated the G's, I added them together and got an equation with just one variable, which I know how to solve. If I want to solve for S, I just divide by negative 4 on both sides. And so we get S is equal to positive 40. And so remember, again, because I defined my variable, and I'm also using a really nice letter, S was equal to the number of seniors admission tickets. So I know that there's 40 senior tickets. So now if I want to find out the number of general admission tickets, I can just take this 40 and plug it back into any of the equations that I started with. I'm thinking that that second equation was pretty nice. So that's G plus S equals 190. So you need to just kind of think about it. The number of general admission plus the number of seniors is supposed to be 190. So if there's 40 seniors, I can already kind of see that the general would have to be 150. I could solve this little equation though, and I get that 150. So again, I took the second equation from my little system, and all I did was plugged in that information that I just found, S equals 40. And so then that tells me that G is 150, which G stood for the number of general admission tickets. And so I've solved the problem by telling it want to know how many of each type of ticket was sold. So there's 40 seniors and 150 general admin. So we have one other method to solve besides elimination, and that other method is called substitution. And so we're going to take the same system, 10G plus 6S equals 1740, and G plus S equals 190, and solve that using this method of substitution, we should get the same answer, it's just a different method. So in order to use substitution, you really want to have one of the equations with a variable by itself. So here would be like something like g equals or s equals. So I'm really drawn to the second equation since it doesn't have any of those coefficients like the top equation does. And if I can make this as g equals or s equals, I can substitute to the more complicated equation. So if I like subtract the s over, I'm looking at this equation, g equals 190 minus s. So to substitute means I take this second equation that I just rewrote and I want to substitute into the first equation. And so what I'll be substituting is this 190 minus s is going to go in place of the g. So that would look like 10 times 190 minus s. That's in place of that g. And everything else is staying the same. But doing that substitution made it so I have an equation now that only has one variable. And so I solve it just like normal. Let's distribute the 10 through. That's going to be 1900 minus 10s plus 6s equals 1740. I can combine my s's together. That's going to be negative 4s. So I have 1900 equals the 1740. Still trying to solve for s. I'll move the 1900 over. Move the 1900 over. So I have negative 4s is equal to 1740 minus 1900, this sounds really familiar, negative 160, divide by negative 4, and again we're getting s is equal to 40. So that means there are 40 senior tickets that were sold, which matches what we just said earlier. Now we still need to find out the general admission tickets. So once we do this initial substitution, we're not done yet. We need to plug that 40 back in, and again, plug it into either place. If I plug it in to the g plus s equals 190, this is exactly what we had before. So we're going to get that g is 150. So it's again, same answer, 150 general tickets and 40 senior tickets. So just this last method was called substitution. And it's really best if you have it where one of the equations is written as g equals or s equals, or it's an equation that's not that hard to isolate one of those variables. However, normally if it's set up like we had at the very beginning, that g plus s equals a number, and then we have g plus s equals another number, often we'll want to turn that into an elimination problem. And that's how you solve a system of equations in two variables.